Okay, good afternoon. So, this class and probably the class on Thursday, I would spend time on trying to help you understand this project work, how it can be attempted. Like I said, this is just one way of doing it. So, this is by no way the model. So, you can feel free to add, but I think what you have to look for when I say today, whether the points of whatever we have spoken in the past classes, which is what is the learning objective of the course, right, is it getting covered in this, that you check up, right. So, it is not so much for the format or the language or the way it is written, that is not very important. What is important is, from whatever I am saying, go back and check up whether all the concepts of the previous classes have been adequately covered in this or not. So, that is what is the purpose. So, first I will start with saying how can be a sample project report looks like. So, I will give you some structure, feel free to use it and accordingly add or subtract. Of course, the starting point is you must have the title of the project. Your project is on what, something that you have to go through. And second is why your group chose that topic, because you could have chosen anything and you choose one, like I gave an example of lithium recovery from sea, then there was water which we are now going to do as a trial, metal air battery, like that there are so many topics are available for you to think through. So, you can choose any topic, but you have to write a short of why you think you chose the topic, and while writing why, make it personal. That means, for you why it makes sense, you write it like that. Do not say humanity requires this, humanity requires a lot of things. So, this is your project. So, your group, if you feel committed to something or if you feel that you want to do something like that, highlight there. Am I clear on this? This is not, there is no answer that if there is a high sounding project means. The second is just only to assess why are you doing what you are doing. Okay. And then the third is basically, of course, always it is when you started deciding to do something, you should go back and see how is it currently being done. Like I said, all things, there is already a existing model. There is very few in life which is completely was not there yesterday, today we are going to come out with this. So, existing technology I have put IES because sometimes there can be more than one technology for meeting that need. So, you have to kind of understand and write a few pages or whatever about currently whatever need of the customer that is there, how is the existing technologies are serving the need. That is a broad thing. So, I have subdivided into some specific points on that. First is you have to write on how do you know what is existing technology. Let us say you are talking about a product to make it slightly complex, but do not choose this, antibiotics. Antibiotics are being made, variety of antibiotics are being made. So, you have to think why you chose this is the existing technology for making antibiotic. It is not very easy, because if you choose a product, then you have to do a lot of reading and understanding to know what is existing technology, because anybody can say, like many years back there is a guy called Ramar Pillai who came, he wanted to make petrol from herbs. So, that kind of things are also available commonly. So, you have to choose why you how did you choose and identify for the given application what are existing technologies. Then local global, we talked in one of the Professor Narajan talked about Indian chemical industry. So, to bring that flavor, this existing technology, is there any difference between India and globally? Globally take a few, I mean you can't cover every possible country of the world, but take any one of them. So, you just have to speculate, is it the same everywhere or if there are variations between the two, that sort of a thing. Then for that technology, whichever one you have chosen, go through the process in some detail. This is an important step, and you have to access the process flow diagram. There are handbooks, there are encyclopedia technology, reference books available, internet is also a good option. You can go through that and figure out what is that existing technology in terms of a detailed process flow diagram, capture that in detail. Then the process flow diagram should have at a minimum typical energy and material consumption, then only it is a process flow diagram, right. If it is just only a line, it does not convey much excepting this is how equipments are arranged. So, you will have to figure out what is the material and energy either throughout the flow diagram or at least inlet outlet, this is sufficient. So, idea is that if you knew this, it will give you a handle about for that process what is the likely cost of making the product, you will get a hang of that. If you do not have this particular information, it is guesswork. Internet again, if you search, people will give you all kinds of numbers. So, this is an important step that you have to go through the flow diagram. Then the flow diagram gives you a second bit of information, which is what are all the major equipments that are required in that process. Not all, because one of the classes I gave you about process flow diagram and P&A diagram, and one particular section of the P&A was horrendous with the level indicators. That requirement detail is not required, but at least major equipments will come in a process. Any decent flow diagram will cover more or less the major equipments. So, understand, list it out, do not say the process flow diagram above has all the equipments listed, you have to pick and write as a table. This has got virtue because the sheer fact that you are reading a flow diagram and writing a table makes you go into some detail and something will trigger in your mind why this, why not that. So, that is what it is. Then if there are anything specific special equipment which you think or which is said in that process flow diagram, it is not made in India as of now, highlight that. So, this gives you an opportunity to know why some things are made in India, why some things are not made. You do not have to go into detail, but at least identify it is said that this equipment circled in red is currently not manufactured in India, whatever. So, that is an important thing I will look for. Then capacity range of plants, this flow diagram is for a particular capacity. Figure out what are the typical capacity ranges. There will not be a single capacity, because people build plants of various sizes depending for their own economic reasons. There can be small size plant, there can be big size plant for the same product. You have to have a feel of what is the kind of thing, and more importantly again to connect the global versus local, you will get a very important flavor. How is it in India, the picture, how is it abroad? Abroad again take some major economy, US, Europe, any one of them you take. So, this will give you again thing is why people are building bigger sizes or why still people are still stuck on small sizes. Both you will not get the answer, but it will give you a trigger for later learning, and therefore, it is necessary at this point just to list that information. What is the typical size in India looks to be, what is the typical size abroad. Then if the same product what you have chosen, is it exclusively only made in India or some of the Indian demand is also being met by imports. This easy to find. If you just search Google, there are Government of India website for Department of Commerce, they list it out. So, it is not very hard to find out for any chemical that you think of in mind, how much is actually imported into the country, the trend graphs are all available there. Again this information I am asking you to come in the project report for your product is, it will give you an idea, are we lot of imports or we are medium import, what is it, why not, do not have to write in the project report why etc., but at least you will come to be aware of the fact that when you are entering some chemical, this is the situation there. Then names of major Indian and global producers for that. Again connect here being that if you are going to be in industry, you should be aware of who your competitors are. Of course, when you go to work for a company, they will tell you immediately, at least during the induction period, training period, everybody will told, this is what we are going to do, these are our competitors. To get you into that groove of thinking, I am now asking you for whichever product that you have chosen, try to figure out who are all could be the major Indian producers and global producers both. Then this product is made out of flow diagram we have seen. This flow diagram is made will be out of a technology, right. Some technology has been used to make the flow diagram. So, who are all the typical technology licensors for this? Licensors mind you are the guys who created the technology, the originators of the technology who created the original flow diagram. So, who are all the typical licensors for the process that you have chosen, figure out and write it out. Wonder if there are any Indian technology licensors, make a highlight, like equipment I said you highlight imported. If you find there is a happy situation that this particular chemical is being made out of technology completely generated in India, highlight it there. I am really looking for that highlight. Then one missing part last is somebody has to build this plant, because we talked about technology, who are making it, that means the manufacturing sector is by and large getting some coverage, technology developers are getting some coverage, who actually builds this plants you have to cover. So, again search and find out who are all the EPCM companies who are building plants based on that technology. Okay. This is all under studying the process in detail. So, when I say study the process in detail, apply your mind to the following factors into that. Now, we have done that. Next step is, after you study a process, class lectures repeatedly said, if look for opportunity if any for improvement, delta improvement, because no process is done and dusted 100% perfect in all cases, it is an evolutionary process. So, you have to know at this time within yourself, think, discuss and come and identify, are there opportunity gaps to develop a better technology. Clear on this? Next is a very key issue. When you say this opportunity comes from several sources. The example of mercury process, caustic soda process, mercury membrane, there the trigger came from several sources. One was this background problem about mercury pollution, Minamata disease and all that, simultaneously skyrocketing energy prices during the 70s and fortunate development of a sodium ion conducting membrane, all of them joined together. So, similarly you have to say, if there is opportunity gaps you spot in that existing process, are these legal, which means man made. Some of them could be, at the moment in India for this chemical there is a very high import duty, which means for some reason our government has decided that we will encourage local manufacturers against imports by making imported product much more expensive, because if somebody wants to import, he has to pay the import duty before the product is used. If you make the high import duty, then the product becomes costlier for the Indian consumer. That gives a window of opportunity for a local fellow, because the local person do not have to pay import duties. So, is that kind of a thing opportunity, or is it some tax exemption? If you make this like production linked incentive, if you these days look at, government is encouraging batteries, number of green energy, hydrogen, all that by giving them tax advantages for a period of time. Are these kind of opportunities opening up for process flow, or simply it is that customers are looking for some solution? Because the first two is can be taken away any point of time. Third, hopefully at least for a period of 10 to 15 years customers do not change their mind. So, that is what you have to pack in your mind, analyze and come forward to say, yeah, in this process I think for these reasons there are technology gaps. Again covers what we covered in the class. Next is this improvement of the process, improvement with respect to what? Not vague terms like it will give you technologically more sophisticated, a plant which has got more flexibility, it will be more environmentally conscious, it will meet the new good, but bring it down to, like Lord Kelvin said, if you measure something, then you are talking about something in a concrete term. So, you have to look for a measurement criteria. So, this improvement opportunity should be converted to a performance metric, some number, some parameter which you can track, and you have to track that against existing process. Clear example being, in the case of mercury thing, if the energy consumption per ton of caustic soda was at the order of 3000 kilowatt hours, you are looking for something which is lower than that in the process. So, that kind of a thing there. Then do some literature survey, both internet as well as serious journals, and depending on the topic, I think somebody asked what are the journals I should refer to. If you come with the topic, at every stage I am ready to help you. This is just only a demo class. So, when the group starts working there, at any point if you get a roadblock, you can discuss with me. Like I said, this is not an exam, therefore, the answers are not hidden from you. This is something to evaluate how well you have understood what was taught in the class. So, I am very, it is like an open book exam. I am available, I know when I am actually guiding you, when I am actually giving you a solution, I am clear. So, you can come back and ask me journal I was referring about. So, the type of topic that you chose, depending on that I can help you identify the suitable journals, you can, I will give a couple of options and so on. Now, has anybody else, because your group is just doing it as an exercise, as a project for one course, but world is consisting of fellows who are already working on this for their life. Like I said, technology development guys are spending lifetime, that David Holloway who is 20 years into steel making by electrolysis. Okay. So, this is available in the journal. So, I can help you locate that. Then locate that and go to like existing process you studied in some depth, the new one you have to study in some equal depth, at least one paper. In that paper, after first try to understand what the hell this guy is trying to do. This itself is a task, it will take lot of time, but please spend the time, it is very useful for you. And then at the end of that work, whatever they have published, the performance metric that you chose, pull that out and say this paper, did it contribute to improvement of that performance metric. First attempt you may find that this is not the case. So, drop that paper, look for something else. So, like I said, I will give you some journal search, I will give you a variety. So, you have to do one or two and then figure out which one probably has some delta as seen by the performance metrics. Then speculate, we have talked about technology readiness level, TRL 1 being idea and TRL 7, 8 is actually plant, right. So, this work, whatever research or improvement work that we have talked about, you have to figure out approximately at what stage of the development it is there. It is much towards this or much towards that by giving a reasoning. It will be a qualitative one, but that qualitative one is exactly what I am looking for. You have to be able to look at something and say this is more or less like this, more or less like this. So, that is what it is, TRL level. Then at this stage you have got some existing process, understood how does it work, base level, performance metric, who are all the people, technology, licensors, EPCM companies, imports, you have got some hang about the whole thing, equivalent to as if you have worked in a plant in a company which makes that product and gained some 2 years of experience. So, you have reached that level more or less, assume. Next question will be, a new opportunity has come, what to do with that new opportunity, it is at this level of TRL. Would you recommend, based on that your analysis, that this we should invest money to bring it up to a higher level, because if that is available right forward, you will lose the cost benefit, very simple. If you spend money on the new idea, how much you will gain, what is the cost of the new idea, one with that, it is not a big shake, it is only arithmetic, your accountant will help you, but this is some of the new ideas may be only at some tentative level. So, would you recommend that the next level of serious funding by establishing, would it be, would you do, on what basis will you recommend? So, this idea is very clear, that is what we have to do. Last two is just for housekeeping. One is, if there are, if you think there are different people contributed in different aspects of this entire project, write that X was involved in this analysis, Y optional, or if you just leave it, leave it. I recommend that you should do that, because at least job clarity within your own team will become very clear, otherwise it will be a mess. I think last date was something like 10th of April, I said 8th of April everybody is sitting and saying, oh my god, day after tomorrow is the presentation, what is to be done. So, avoid that very clearly. So, contribution member forces you to think and allocate work among yourself, start discussing in a very coherent manner and things like that. Again, I am not going to use this contribution for differential grading unless you yourself come back and say, in my group you can have differential grading. If you say that, I will do, otherwise it is just for helping you, everybody in the same group gets the same grading. Okay. If you have used, you will use a lot of references, obviously this is a huge effort. So, you have to list some list of references like in journals, previous work, something like that. So, for each one of them wherever you have collected the information, just refer to the source, whatever it is. So, this is the sample suggested format of doing the project work. I am going to post it on Moodle, so it is available for you to go through. Now, with this in mind, I will try to convert some of this Actually, if I had written a project report on this water similarly, it would be nice, but I can't write it in 3 days time in spite of the fact I try hard. So, instead I am going to give you ideas in the form of a presentation, where most of these ideas will be the points what I covered will get covered hopefully. So, let us start with that. This was the topic that was said in the class, saying that okay, you take a sample topic like affordable potable water on a large scale. I have just cut and pasted the same title and underlined these two, because this is the first trigger that came to my mind when I chose a topic. What are we saying is, it should be a potable water, it should be affordable. So, which means what? Affordable, something I should have, and it should be on a large scale. So, these are the 3 keywords my group, which is myself, talked about it. Again the approach, again I am repeating it for the nth time: study existing one, completely process flow diagram, look for opportunity, blah 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 blah. First, potable water. So, I started by saying what is the product that we are talking about is drinking water. Drinking water, there must be a standard. There is a standard. The IS 10500 standard is the latest standard which is available for India. So, this gives it is a large, it is a 10-12 page paper, it is common, if you just Google you will get it, it is available. But I have just picked up only the most important ones which has got some relevance to the treatment process of the various water methods is. So, I just picked up only one other. The first one is called TDS, total dissolved solids. Even though water is clear, of course, it has got dissolved solids into that. So, there is a limit on to that total dissolved solids. You can see it is a little bit of a leeway here, Indian standards. If you, I wish some of you will later on, out of interest, go back and look at Deutsch standards, DIN standards for example, or it can be taken as BIS, British standards. Every country has its own standard. I doubt whether this wide leeway of 500 to 2000 ppm will be given in other countries. Our country says, yeah, 500 to 2. There is a reason for that, but for the present we are just observing, oh, there is quite a lot of it. And then various parameters, chlorides, sulfates, calcium, magnesium. And the last bit, total hardness, is important to remember, because the calcium and magnesium, the first 2 lines 75 ppm is as calcium ions, magnesium ions. They also finally calculated back into in terms of hardness. This hardness is for historical reasons, some unit CaCO3 it gives. If there is calcium, actually calcium is present as calcium chloride and calcium, maybe mostly calcium chloride because it is soluble, but it is expressed as CaCO3. What reason I do not know, it is just a practice. So, the 200 ppm is all calcium converted to CaCO3, all magnesium equivalently converted to CaCO3, and so on like that. So, this is what it is. And of course, that water should not have any color, odor, pesticides. So, this is the water quality there. Now, how is this water quality currently met? That is the next step. So, we understood the product, potable water, this is the standard. How is it currently being serviced is required. This is a big thing, because depending on the customer, this might slightly change. So, because it is large scale, I have decided to take an example where most of the times what is used. So, do not come back and ask me saying this, this Himalayan pure water which is bottled. Here I am going to say large big time is most of the plants are built on the basis of there is a water source nearby, usually a lake or a river. So, you go there and this water is present, test that water. Most of the times, because it is rainwater accumulated in both cases, right, see river as the TDS dissolved solids will not be very high. So, instead it might have some turbidity because it is just open, dust is falling, leaves are falling, whatever is happening there. So, the process that has been worked out and it is in practice is draw water from there, remove the suspended solids, and then water is now clean and clear. You do not do anything about TDS because TDS is within that range, but there may be some pathogens like virus, E. coli, what have you. So, you disinfect, use some chemical to kill all the pathogens, store, pump it out, that is it. and a system of pipelines that between the water treatment plant and wherever it is used, overhead tanks and pipeline, underground tank, all that goes through that. Finally, the water either goes to the sump of the doorstep of a final customer or it goes to a community fountain. Both practices are existing. If you go to, let us say, typically in a town, large town or cities, the expectation is that at the entrance to your flat at one point they will give you that water. Of course, you do not take it up to the 20th floor because the pressure will not be there. So, it will come into a sump and fall into the sump. Subsequently, you do whatever you want to do with that. In many rural areas, if you go, the concept of taking the piped water right up to their kitchen or does not exist. So, it will probably be in every street corner there will be a community fountain into which water is made available. People just go collect that water and come back. So, that is what is it. I am leaving out things like if you are fortunate in your own house you are able to put a open well and draw water, well and good for you, but that is not large. So, that is it. Okay. Actually, I thought of, I will write out a flow diagram. The flow diagram bit I am skipping, but you can refer to any book and see, you will very clearly say there is a river intake, lake intake, intake structure which is a pump pipeline business, then it pumps water to a treatment plant, then there is a flash mixture, in the flash mixture you put all this flocculants, then it goes to a clarifier, in the clarifier the suspended solids are settled, overflow goes to another pressure sand filter whatever filled up, then there is a chlorination facility, pump and goes. So, the flow diagram is to be written, but I am skipping that because I did not have time after that. Then I went back and speculated about this plant. Usually such plants are of that size, what I have said, 10 million. The convention in the water plant, potable water plant is to define the capacity as liters, million liters per day, that is a nomenclature, makes sense. You could have called tons per day, but because people drink water in probably in liters, so it is written as million liters per day. So, 10 to 50 million liters per day is a typical plant size. Why 10 to 50 million liters? Depends on the source, because if you put very large plant, let us say, there is no theoretical limit for why it cannot be a 500 million tons per day. You can build a 500 million per day plant, but if you then you have to have a source of lake or river from which it should come, and then this 500 million liter has to finally land up in wherever it is. So, it is sometimes a problem. So, usually if you see in the hinterland areas, non metro cities, the next slide will tell you, people will may do it in small bits and pieces, pick it up from here, find another lake there, find another river from there, like that it is geographically the intake is spread out, keeping in mind where the final point of consumption and the pipelines are drawn like that. So, typical plant sizes are like this. The guideline varies. In fact, if you research, this is a big topic, there are affluent communities where people use 800 liters per day and complain that water is not enough, and there are chaps in Chennai average is about 110, 115 liters per day average. So, some people may be low. So, on that basis if you see, these plants will meet 60,000 to 3 lakh population. So, that makes sense, right. If you are lot of towns, small villages, so accordingly you will choose the capacity of the plant, look for a source, put it up there and hope for. The investment cost of such plants, actually how I arrived at it is, you have to write the flow diagram, write out the various equipments, tank, pump, pipeline, clarifier, filter, another tank, chlorination system, try to work out the cost for all the sizes, add it up, it will come. It is 10 crores. Normally the land is government land, so you do not take the land cost into it, because you do not want to put a water treatment plant in a private property and tomorrow the fellow says, so it is a problem. So, similarly the distribution lines are very difficult to predict, it depends. The same plant can go a radius of 10 kilometers, it can go radius of 20 kilometers, whatever. So, it is very, so leaving those two parts, roughly ballpark cost is this. I am giving these numbers because it is important to work out, finally you must have this performance metric, no. So, I am trying to drive at that. The typical operative capital cost, that means investment cost I have shown here, the typical operating cost, how much does it cost to run the unit, more or less say, what is involved in this, incoming water that is required, normally you do not pay. I mean, if you draw water from a lake or river, as of now people have not paid anyway. So, there is no payment on that, and therefore, we can, and almost 90, 95%, 98% of the incoming water can be converted into potable water, because the wastage is only like settling, sludge comes out, some dewatering. So, practically it is a very efficient way of taking water, there is no wastage by and large there. So, if you take the other consumption is lot of power is required, pumps here and there, electricity, control system, all that energy that is required, plus some chemical, this flocculants which are used to suspend. So, if you take these two and add up, you get at the outlet of the plant gate, because then the piping cost I have included depends on the length. So, that is the cost. So, you have got two numbers, and these two numbers I am going to use like a performance metric, which is how much does it cost to build a plant, how much will it cost to operate that plant. How much will it cost plant? I have said this crores. So, how much will it operate is this. Now, I converted that into all per consistent unit in terms of meter cube of water. So, in the variable cost equivalent to operating that, you can see it is of the order of per 1000 liters 1.5 rupees. This is an important point. Our water treatment plants which are commonly existing are existing for a good reason, because that is the most efficient, cheapest way of making water. So, it is, remember that number 1.5 rupees per meter cube, or it is for 1000 liters 1.5 rupees only is the cost of that water at the plant gate. But that is not the only cost, because we will know there is a something called investment, and therefore, there must be a return on whatever it is. So, I have tried to work out plus some operating cost I put through that will work out to actually very large, more than the variable cost. In this case, setting up and fixed cost is bigger, that is 10. So, if I round off 10 to 12 per meter cube or 10 to 12 rupees per 1000 liters divided by that, it will be few paise. So, that is the benchmark. So, you have got an existing methodology, capital cost, variable cost. This is the performance metric I am going to use for all so called improved technologies that we hear about for making water available for large number of people. You must have a benchmark, this is the benchmark we have tried. Flow diagram we will skip. Now, spot for opportunities, right. Is this existing one, if it is all good, is it, or is there any loopholes in this, that phase. What is the issue with this method is, the source is river or a lake, and you sometimes find there is nothing close by. I mean, when I say close by, it should be probably within 5 kilometers, 10 kilometers, 20 kilometers, seems to be reasonable. If 200 kilometers away, if I have to save water, it becomes hard. It is not impossible, it is a bit hard. So, that is one. Secondly, even if there is a source when you saw, it should be available throughout the year. This is again a problem, because the source, if it is a lake and the lake got water only during the monsoon time, before the next rains comes, you may find that the lake is dried, people are playing cricket. Actually, Veeranam, there is a place called Veeranam in Tamil Nadu, it is about 200 kilometers south of Chennai. It is a big lake, it was built during the Chola period, 900, 800 AD, very, it looked like a sea, huge one. So, that dried up in that period when I was a student here, and we went and found actually for the first time people have seen what it is the bottom of the lake, and guys were playing whatever game it is. So, this is a problem with depending on lakes. Rivers also, some rivers, at least most of the rivers in southern part of country, they do not run throughout the year. Maybe Ganges is probably, because I do not know, that also probably the level goes up and down. So, this is a problem with that. So, two issues we have spotted is this is all fine, but there is always a bit of uncertainty about that. Other one is a management operational problem. These plants, like I said, are typically meeting 2 lakh people, 1 lakh people requirement, and you know how many people are there in the country. So, there has to be a very large number of plants even in a state widely distributed, 100 plants, 200 plants. Operating the plant consistently to make sure that the potable water quality is correct is not an easy thing, because these plants, what can you automate? You can automate level flow controllers, but when the incoming water quality slightly changes, more turbidity, less turbidity, it is very hard to automate that sort of a thing. Secondly, to have people who will sit 45 kilometers from the nearest town and operate this is also not very easy. There is a real problem. You need to have the guys who are from there and with their knowledge you have to go through. So, diligent operation to ensure quality of the plant is a problem. What is not a problem probably is variable cost. For 1.5 rupees per 1000 liters, what are we talking about? However, here also technology has continuously responded to the opportunity is that always look for slightly more efficient way of doing the same stuff at a slightly lower cost. For example, in one of the equipment I said is about something called a clarifier. Some of you must have studied in basic unit operation. The clarifier is a circular vessel, it is kind of circular at the top and conical bottom, and inside that there is something called a rake, which is a very slow moving paddle like thing which is slowly moving around. Look it up if you have not gone through that. Clarifier. Purpose is when there are solids which are settling by gravity, it kind of compacts those solids and brings them to a more pumpable slurry to the bottom, and the top becomes clean of solids. So, the overflow is clear, the underflow which is at the bottom will be a slightly slurry kind of a thing there. So, these are clear, not a big deal, these are steel equipment, it is not high pressure, high temperature, water, but nevertheless clarifier has to be correctly positioned, level, occasionally it develops cracks, leaks, holes. So, people have looked at, and it occupies a lot of diameter, because if you have to have settling of the suspended solids, you must have low velocity and therefore diameters are big. So, technology, settling studies, simple thing like that chemical engineering has come out with an equipment called lamella clarifier. These are a system of inclined plates or tubes which cut down the size of the clarifier by almost 40-50%. Or if you have an existing plant, if you put this lamella clarifier ahead of that, the capacity goes up by twice of that section. Of course, you have to take the front end and back end section. So, that has come out like that. And then self cleaning filters, this filters, sand filters, usually they are open vessels, you pass, water percolates through that and then comes out. After some time it will get choked. So, you have to rake it up and clean it, otherwise water will not flow. This has been automated based on very nice devices like pressure drop sensors. When it goes through that, another pump starts, opposite direction it flows, all that has been done. Now, this is the story about one of the ways of doing large population water affordable being met. There is still some problems with that. The biggest problem which we have stated and come away is what happens if throughout the year this lake or river does not exist. The problem becomes absolutely acute as the population increases. Here is a table where I have taken 150 liters per day per person and I have worked out in some size, very interesting. If you go through, maybe village, nobody creates a water treatment plant for a village, for a particular village, probably it will be a town which will also feed a village, because you need to have some size of the plant, right. You do not put a 1 liter per hour pump in the river and take the water from there. So, because of common sizes up to like I have converted that into a 3 lakh, 4 lakh population, one water treatment plant will be set up. But if the metro, and these metros are now sharply increasing, number of metro cities in India is probably about 40-50. In the original days it used to be Delhi, Mumbai, Calcutta, Chennai, Bengaluru, Hyderabad, stop. Now I can't even count, it is probably 50-60 there, because such of the small towns are also having this other metro which is this train service going through. So, if that is the level of population increase, if typically a metro means 20 lakh people are there, 2 million people are there. So, for them where is the lake, where is the river? Not always, and mostly these are away from those places. So, the water requirement is sharp. So, the availability problem becomes absolutely problem as the size of the population becomes bigger. Therefore, there is another process for meeting affordable large for this segment, which is desalination. I suppose not all, most of the metros are near a sea, most. Do not tell me Delhi, coming to Delhi, Jaipur I am coming. So, if your city is also very close to a sea, then there is a process called seawater reverse osmosis, which works osmotic. I will not go into all that. So, it is very clear, osmotic pressure, reverse osmosis. So, water only will, it works on the principle of a semi permeable membrane, which under some conditions allow only water to come out and the salts are retained. So, this is been practiced, plants have been built, very large number of locations in the world where similar problems existed, where there is no nearby source of water and big capacities 100 million, 200 million, 300 million, 400 million liters per day of plants. But here the thing is, you can't convert 100% of the sea water into potable water, does not make sense, how can you? So, the best design plants as of now, 45% of the sea water gets converted into potable water, and the balance 55 gets enriched, they have to go back to the sea. So, keep that in 45, there it was 95, 98% of the water came, here of course you have to bring it down. This process flow right now allow me to skip, because in the next class if I start I will not be able, in the next class I really want to go through the flow diagram because it is very important. I will jump to assuming that we have gone through the flow diagram, equipment listing and all that. Now, I will come down to performance metric. Here the electrical power requirement is higher, because you are going to have high pressure equipment. Reverse osmosis, if it has to work, it has to be at a higher pressure, therefore, the energy consumption goes up even within the battery limits of the plant. It is about 4 units of power per cubic meter of water output, all inclusive, intake, within the plant, high pressure pumps, AO, everything. There are chemicals to be added here also for that. So, if I take the power cost and the chemical cost, convert them into equivalent rupees per meter cube, this comes to 25 rupees per cubic meters. There what did we saw? We saw something like 10 to 11 rupees, right, 10 rupees on the fixed cost, and this here variable cost itself is coming to 25. Then similarly, the investment is not free. So, I have given some investment numbers, again you can go through, all this is available in the literature survey. 200 MLD plant, Chennai has got 100 MLD and 400 is being built. So, 200 MLD plant, that is the money that costs, it costs a lot of money. You will know why if we again next class we go through the flow diagram. Now, convert that fixed cost also into per meter cube, that is coming to 60. So, here the variable cost is something like 25 rupees, the fixed cost is 60, total is 85 per 1000 liters, compared to our conventional drawing water from the river and the lake is 10, 12, 10, 12 compared to 85. So, it is expensive. This is the table. I have given performance metric of that is, I have chosen 3 performance metric. What is the sizes in which these plants can be built and has been built? Of course, theoretically you can say what is the problem, why can't you build? Theoretically anything can be done, but we are just being engineers, what is reasonable, there are lots of scale up, everything is there. So, what as typical sizes I have given in million liters per day. I have given the operating cost, which means power, chemicals, all that goes as consumables in the plant per meter cube of water produced, and how much money will it be required to set up a plant of that size as rupees crores per MLD of capacity. This is very clear, no? Which means if you want to set up a 100 MLD desalination plant, first column 9 crores per MLD, 100 MLD 900 crores, ballpark plus or minus something will be there. With this, let me also talk about issues with RO plant. What are the issues? Now, when I say issues, I am avoiding political issues from everywhere, because this is no end. For everything you say there will be 5 views, wait a minute 6 views, because one fellow changed his mind. So, that is not the engineers can work on, you have to go with the technically evidence based facts, which is, it is a fact that these plants, the output performance is quite sensitive to the incoming water quality, because here the incoming water is from the sea and sea is like a living, it is a living creature. Its composition, behavior changes, like I have been a seaman, incredible changes take place. So, before building the plant, what you will do, you will probably go draw a sample. Clever fellows will say, acha, today we have taken 27th of February, you can't go on one sample, let us do one thing, we will have a 6 month sampling program and then take. Another clever fellow may say, no, no, wait, there are 4 seasons in a year. So, if you take the first sample on 27th February, every 15 days till next 27th let us sample and then try to design the plant. This all has been done, then you find still there is a variation. So, the sea water quality has been a major issue, and based on that the performance of the plant, particularly due to the live organisms in the sea. It is not a chemically a problematic area. There are so many life forms that are living in the sea, they create havoc in the scaling, fouling, etc. So, that is one. The second one is of course in India specific, the first one is global. The second problem which is specific to India is all the membranes as of now is 100% imported. There is no one person who is making membranes in India. So, this is that red circling which I said. 2 more minutes then we stop. Now, affordable. So, we have called about how existing method summary what has been done is one type of application, there is lake, river, water drawal setting up of the plant. Another type is seawater RO. I have given you the performance metric of investment cost per MLD, operating cost per meter cube of water, typical sizes in which they are paid, issues with respect to this, issues with respect to that, some problems, technical problems still which are open, that is there. I will spend a little bit on the affordability and stop, then we will continue in the next class, because affordability was in the title, right. So, we have to say, first question is what is this affordability? The affordability is very again a political term. If you ask me, I purposely put, because what is affordable to one guy is probably opposed by another person, right. So, we should keep that in mind before we get into any major decisions. Let us simply talk about, forget affordability, because it says as if it is related to the capacity of a person to pay. Instead of that, what is the cost, that is clear, so nobody can dispute, cost is supported by a number. I gave the numbers for the cost. What happens today is that almost all over in India at least, and I think it is the global practice also, public water distribution is free. You expect there is a water tap provided, open, take, nobody will say wait, pay for it. So, this happens. So, it is free. So, there is no income stream, but in order to make that water, whether by A process or B process, we have seen what will be the cost of generating it, but luckily it turned out to be few rupees per 1000 liters. So, we might say after all sir, I am not going to drink 1 meter cube of water, do I am going to take 200 ml, 1 glass, do not come and ask me for $5. So, that is what is the real intelligent practice in India. I gave an interesting example, take Chennai, which is a city where water is delivered to your doorsteps more or less. This is the kind of a payment that the government agency which is providing the water is getting. Look at that number. Not even 1 paise per liter. That is the thing. And how much they spend, if you go back and see, if they got it from a river, lake, etc., it is 12 rupees per 1000 liters. So, it is 0.12, 0.2, array yaar, what are you fighting about, that is all the cost, give it na, get rid of it. That small amount of money, let from a tax whatever you pay it, do not ask me for that, that is the principle. But where it is slowly getting into a problem, go back to the real, is there anywhere you have gone, opened a public tap and found 24/7 clean good water comes? Not because of somebody is messing it up, it is because the sources are drying up. Secondly, if you not to build a new plant, because it is not earning any money, you have to decide public gesture, acha we will build one more plant. Why? because we want to build a plant. Unlike ROCE, there is no ROCE business here. What is ROCE? Okay. Keep that in mind. 12:50, so I will, yeah. So I will stop here and continue from the next slide in this. So this is the next probably Wednesday class will be with an external speaker. I think he comes from an EPCM background. Then Thursday when I come, I will go through the rest of the thing and still identify what is the delta opportunities, what can be done for that, what to think.